I am Shamsunisa from Royal Degree College, Chemistry Department. As we are dealing with Unit 1, Inorganic Chemistry, in which Chapter 1 is our chemical bonding. Today we'll study about FAJAN'S rule, polarity and polarizability of ion, use of FAJAN'S rule, factors affecting polarization or covalent character in ionic bonds. FAJAN'S rule, polarity and polarizability of ion. The rule deals with the covalent character in ionic bond. Due to difference in electronegativity in bonded atoms, polar character arises in a covalent bond. It has been observed that some covalent character is also present in an ionic bond. Consider lithium chloride molecule Li plus Cl minus. Due to difference in electronegativity of lithium 0.1 and chlorine electronegativity is 3.0, it is expected to be purely ionic compound. Its solubility in organic solvents indicates that it possesses covalent character too. Such behavior of ionic compounds is explained by FAJAN'S rule. Use of FAJAN'S rule. It helps to know and compare the covalent character among different compounds. When a cation comes close to an anion to form a compound in which two effects takes place. The first one is the cation attracts the outermost electrons of the anion towards itself, and second one is the positive charge of the cation repels the positively charged nucleus of the anion. As a result, cation pulls the outermost electron of anion and anion gets distorted and the electron cloud of anion is tilted towards the cation. Thus, the shape of the anion changes. The power of an ion to distort the electron cloud of another ion is called its polarizing power. And the tendency of an ion to get polarized by the other ion is called polarizability. As the size of an anion is larger than cation and its electrons are less tightly bounded to the nucleus, it possesses high polarizability. Greater the polarization or distortion, greater is the covalent character, and lesser the polarization or distortion, lesser is the covalent character. Next is factors affecting polarization or covalent character in ionic bonds. Three factors affecting polarization or covalent character in ionic bonds are: first one is small size of cation, second factor is large size of anion, and the third one is high charge on cation. So we'll see first of all about the small size of cation. In a small size cation, concentration of positive charge is very large. So it attracts the negatively charged cloud of anion strongly, polarizes it, and induces the covalent character in the compound. Thus, the covalent character induced by the large size cation will be lesser than that caused by small sized cation. It includes different cations with same charge and same anion. For example, consider Li plus Cl minus and Na plus Cl minus. Here, cations Li plus and Na plus have same +1 charge, where Cl minus anion is same in both the compounds. It has been found that smaller sized cation compounds are more covalent than larger sized cation compounds. Since size of Li plus is smaller than that of Na plus, so lithium chloride is much more covalent than sodium chloride. Sodium chloride is ionic in nature. Similarly, size of Be2 plus, that is 31 picometer, is smaller than that of magnesium ion 65 picometer in their barium chloride and magnesium chloride compounds. So, Beryllium chloride is much more covalent than magnesium chloride. Greater the covalent character, smaller will be the melting point of the compound. Next is large size of anion. Larger the size of an anion, less tightly its electrons will be held by the nucleus. Hence, these are largely polarized and large covalent character is induced in their compound. It includes different anions with same cation and same charge. For example, consider Li plus Cl minus and Li plus I minus. Here both compounds have same charge, Li plus. The anions Cl minus and I minus are different but have same charge -1. It has been found that larger sized anion compounds are more covalent than smaller sized anion compounds. Since size of I minus anion is much more than that of Cl minus anion, so lithium iodide is much more covalent than that of lithium chloride. Similarly, it can be explained that out of calcium chloride and calcium iodide is polarized more than calcium chloride. Since size of I minus is greater than Cl minus, so calcium iodide is more covalent. It is showing less melting point. How much? 375 Kelvin than calcium chloride, which is showing the higher melting point. How much it is showing the melting point? 772 Kelvin. The order of size of halide ions. Here you can see the order. Iodide ion, it is showing more size compared to that of bromide ion. Bromide ion size is more compared to that of chloride ion. Chloride ion size is more compared to that of fluoride ion. It means that fluoride ion is lesser in size and the iodide ion is greater in size. The order of covalent character in their compounds with a calcium element will be like this. Calcium iodide, it is showing more covalent character compared to that of calcium bromide. Calcium bromide is showing more covalent character compared to that of calcium chloride. Calcium chloride is showing more covalent character compared to that of calcium fluoride. So the order of melting points will be like this. Calcium iodide, it is showing less melting point compared to that of calcium bromide. Calcium bromide melting point is less compared to that of calcium chloride. Calcium chloride melting point is less compared to that of calcium fluoride. Means that calcium fluoride is showing more melting point compared to that of calcium iodide. Now we'll talk about high charge on cation. A cation with high charge, that is magnesium ion, aluminium ion, silicon ion, that is Si4+, phosphorus ion, P5+, and the chloride ion Cl7+, must have small size. Though ions like P5+ and Cl7+ have doubtful existence, yet if such ions exist, their high charge combined with small size would cause them to polarize some adjacent anions and form a covalent bond. Greater the positive charge, greater is the polarizing power and greater will be the covalent character in the compound. Greater covalent character, smaller will be the melting point. It includes compounds of different cations which have different charges but have same anions. For example, consider Al3 plus Cl minus thrice, Mg2 plus Cl minus twice, and Na plus Cl minus. Here the cations Al3 plus, Mg2 plus, and Na plus have different charges. That is, aluminium ion is showing the charge +3, magnesium ion is showing the charge +2, and sodium ion is showing the charge +1 respectively. These all compounds have same anion, that is Cl minus. It has been found that the compound whose cation has greater positive charge would polarize adjacent anion to greater extent. So, that compound will have more covalent character. Greater the positive charge on cation, greater is its polarizing power, and greater will be the covalent character in the compound, and lesser will be the melting point. Since positive charge of Li3 plus ion is greater than Mg2 plus ion, Mg2 plus ion is showing more positive charge compared to that of Na plus ion. So covalent character of aluminium chloride is greater than that of magnesium chloride. Magnesium chloride covalent character is more compared to that of sodium chloride. Thank you for listening my lecture.